Hello and welcome to this video about power. In your equation sheet you will get given this equation: power equals energy transferred divided by time. What you need to remember is this could also mean power equals work done over time, because from previous videos hopefully you'll remember now it's really important that work done is energy transferred. So if asking you a power question, they might say calculate the power of something, and they might give you in the question the work done and the time, and you need to remember that work done is the same as energy transferred. Now they won't give you the units for power, energy and time on your equation sheet, so you need to remember that power is measured in watts, energy transferred is measured in joules, and time is measured in seconds. So if you see it in anything other than these units, you will have to convert it most of the time. The only time that you might not need to convert it is sometimes they talk about energy transferred in kilowatt hours as opposed to joules, and if they do that and the power is already in kilowatts, then you can leave it because you need the power in kilowatts and the time in hours. But normally you'd have to make sure that they are all in watts, joules and seconds. But just bear in mind, if they give you the units kilowatt hours, so if they have a question and they've got the answer line there and the units are there, you may well get a question related to power where the power is in kilowatts and the time is in hours, and that's absolutely fine. The key thing is just to really pay attention to the units that you are given, if they give you the units at the end of the question, and then you can work out what you need your units to be in. So power then, power ratings should be on most or all of your electrical appliances, and they tell you then how much energy is transferred over time. So for example, 10,400 watts for this oven compared to 60 watts for this lamp. So the oven would be transferring a lot more energy over time compared to the lamp. Or we can say that the oven is doing more work over time compared to the lamp. So a faster rate of work done in some appliances compared to others. Sometimes you will see these kind of things in kilowatts. So if we transferred that to kilowatts, that would be 1.2 kilowatts. So just bear in mind that if you do need to transfer kilowatts to watts, you will need to times by 1,000 to make 1,200 watts, for example. Or in the other way around, if you need it in the other way around, you have to divide by 1,000. So transferring kilowatts to watts is something that you might have to look for in the question. Okay, a couple of questions then relating to power. You've got the equation up here. What you need to watch out for is that they're in the correct units, so that over here you've got power in watts, energy in joules and time in seconds. If it's not in those units, you might have to convert them first of all. So if you have a go at them on your own, pause the video and then come back and see if you got them correct. So first question, calculate the power rating of a microwave that transfers 48,000 joules of energy in 60 seconds. So we've got our joules in the correct unit and our time in the correct unit, so we simply do P, power equals energy, 48,000 divided by 60, and that will give us 800 watts. And down here we've got a motor transfers 4.6 kilojoules of energy in 2 minutes. Calculate the power output. So in this one, a little bit trickier. They don't have many of these on the foundation, just maybe one or two, but you need to recognise that that's in the wrong unit. That needs to be in joules. So to do that, to calculate in joules, we times by 1,000. So that would be 4.6 times 1,000, which will make 4,600, 4,600 joules. And this is in the incorrect unit because that's in minutes, that needs to be in seconds. So if we times by 60, because there's 60 seconds in a minute, we will get that as 120 seconds. Then we need to then use these numbers, our energy and our time to calculate the power. So P equals, I'll do that in a different colour for you. So P equals 4,600 divided by 120, and that will give you 38 watts. Okay, for your foundation, you can stop watching there because that's probably the most difficult type of questions that we ask for power. I've put a couple of trickier ones on for people taking the higher tier as well. So a couple of questions for higher tier. If you have a go at these, pause the video and then come back and see if you got them correct. So this time it's asking for the energy transferred by an 800 megawatt generator in 1 day. So it's asking for this time the E, and it's given us P, but it's in megawatts and not watts, and it's given us time, but that time is as 1 day. So we've got quite a bit to do here. First of all, we need to rearrange the equation. So we need to make this E equals P times T, because we've just times both sides by T. And then we need to put these in the correct units. So this mega stands for times 10 to the 6. So we've got 800 times 10 to the 6 watts. Okay, so this is 800 million watts, but I'm just going to put it in the calculator as 800 times 10 to the 6. And over here we've got time in 1 day, but we need to get that to seconds. So I'll just do this over here. There are 24 hours in a day. There are 60 minutes in each hour, and there are 60 seconds in each minute. So if we do this calculation, the hours times the minutes times the seconds, that should give us the number of seconds in 1 day. And that would be 86,400 seconds. So then we just need to multiply these two numbers together. So we get E equals 800 times 10 to the 6, because that is our power, multiplied by 86,400 seconds, and we'll get the energy transferred by this generator as 6.912 times 10 to the 13 joules. And if you get a number like this, you can just write it down in the standard form like this, 6.912 times 10 to the 13 joules. If I just clear that first question, we can concentrate on this one now. So for this second question, you need to calculate the power output of a person that climbed a 20-metre vertical ladder in 15 seconds. The person had a mass of 50 kilograms, and this is the gravitational field strength. So just annotate it with what you've got. You've got P for power, you've got a height, you've got a mass, check the units, yep, kilograms, meters, good. Over here we've got a time, and here we've got a gravitational field strength. And straight away I'd look at my data sheet and try and find an equation that links P, T, G, M and H. And then I panic because I wouldn't find one. So I've got to think to myself, what equation can I do with the information that I've got? And if you look, you can multiply the G by the M by the H to get the gravitational potential energy. So we'll do that first of all. So we've got gravitational potential energy equals mass times gravity times height. So gravitational potential equals 50 times 10 times 20, which equals 10,000 joules. And once I've got that bit, then I can then think about what else I can do to calculate power. And I remember that power equals energy transferred over time. Now I've got myself an energy transfer, so I calculate P equals 10,000 divided by 15. And that will give me a power of 667 watts. and I've just rounded that one up to 667. Okay, so a few complicated questions that they might ask you. You need to remember that the units are measured in watts, and just bear in mind that they will have complicated questions like this on the higher paper where they combine the ideas of power and energy. You have to look in there, calculate the energy first, and then calculate the power afterwards. I hope you found this video on power useful. If you did, please press the like button below and feel free to subscribe. Thanks for watching.